Right, okay, so we're going to do Laplace question 3 now. Okay, so again, at the front here, or the front of the document, which you can now see in the video, I've put the table of Laplace transforms. Now with this question 3, you need to go backwards. You've been given, with all of these, you've been given f of s, and you've got to work out the original t. So in the table, you've been given this side, and you've got to go backwards to this side. So every time, we're going to look at which one of these matches up to what we've got, and then match it back that way. And this is going to be our answers now. So these are the questions, these are the answers. So again, I've called them row 1 to row 9. Okay, same as before, and that's going to be my reference. And through the questions, I've set it up, so I've already written which rows, so I don't have to keep flicking backwards and forwards. Right, so 3A, we are given, we've been given the f of s. F of s is 1 over s plus 2. So if we look on row 4 of the table, which is what I've highlighted here, in fact I'm going to do this in red because it stands out a bit better then. So the question is f of s is 1 over s plus 2, and it's find f of t. So what is the function that when we apply the Laplace transform we get 1 over s plus 2? So if we look at row 4, look, we've got 1 over s plus 2, so a is 2. So here's the answer with a is equals to 2. A is 2, so it's e to the minus 2t. Okay, B is, the question is f of s, there it is at the top there, f of s is 2 over s plus 5 plus 1 over s minus 2. Now this is 2 of row 4, the 1 over s plus a added together. The first one's got a constant 2 multiplied here, so that gives us a k in the front here. Okay, so what we can say, if you've got a k on the top, it multiplies the e to the minus 80 in the front. So this one here, we've got k is 2, and looking over here, look, k is 2 and a is 5. A is 5, and this one, if you like, the k is 1, and the a is minus 2. So we've got 2 of them added together. So it's going to be 2e to the minus 5t, and then it's plus 1 over, this is f of t. That's the answer there. F of t equals, oh sorry, it's not 1 over. It's, I get distracted. It's plus 1 e to the plus 2t. That's your answer there. Okay, so there you go. So that's how to do those. So it's using the table in reverse. So for C is f of s is 5 over s plus 1 squared plus 25. So if you look down the table, on the right-hand side, you come across this one. And look, our omega is 5, omega squared 25, and a is 1. So we can use this one. Omega is 5 and a is 1. So we can have f of t is e to the minus 1t sine of 5t. And there we go there. Okay, so that's those first 3 done. So we can turn the page now for part. I've already checked these as well, so I know these are all right with the mark scheme. Okay, D. So the next one. Now this one, D, we've got f of s is 27 over s squared plus 45 plus 13. Okay, so now what we need to do first of all, when you look on in the table, the sides that we need is going to be one of these. And we need to complete the square in the denominator of these ones. Let's just have a little look at the table. Yeah, they're the only ones that can be this one here and this one here. Or it's one of these, this or this. So, and both of those are given with a completed square. So we need to start by completing the square. S squared plus 4s plus 13. If you remember, that's s plus 2 squared. Okay, so what I've done is I've halved that 4 there. Okay, now, so it's when we multiply out, s plus 2 times s plus 2, we get s squared, 2s, and 4. So we've definitely got our s squared. We've definitely got our 4s there. We've got plus 4 there, and we need plus 13. So we've got to add 9. Okay. Now, these here, they've both got s plus something squared, where our a is obviously 2. But then omega squared is the next one. So because we've got a 9 here, it means our w is going to be 3 in the bottom there. So if we like, this is going to be s plus 2 squared plus 3 squared. Okay, so we've got this bit sorted out. So on the top, we haven't got an s on the top, so we don't want this one. This one will come up in this other one actually, for part E, because where we've got an s on the top. So we definitely want this one for part D. So it's this one for D. And our omega is 3. So if we put all this together, we've got 27 divided by s squared, let's get that right, s squared plus 4s plus 13. We need a 3 on the top, because it's got to be, we've got 9 there, which is 3 squared, so we need to have 3 there, divided by s plus 2, I've done that again, s plus 2 squared plus 3 squared. Okay, so that's in this form. Look, 3 squared, s plus 2. But what our original one, we've got 27 on the top, so this is actually 9 times 3. There's 27 there. Okay, so if this is our f of s, our f of t is going to be this right-hand side with a as 2, omega as 3, and an extra constant in the front there of 9. Okay, so if you like, I've done that, what did in the other one, k there, So we've got k is 9, a is 2, and omega is 3, and this is on row 9. Okay, so it's going to be 9 e to the 2t. I believe I've missed a minus sign off there. Yes, I have. There should be minuses in there. E to the minus 2t. And then you don't have to memorise that. That's given on the formula sheet. And then it's sine of 3t. Okay, and I've already checked that one. So that one's right there. Okay. So that's there. Okay, I think in the other one I coloured in these rules. Let's just put this in here. E to the minus 80. E to the minus 80. So I coloured in the rules with peach before. That's e to the minus 80. That's row 8. Row 9 with the extra k in is there. Okay. Right, E. So for E, we've got s plus 5 over s squared plus 4s plus 13. So again with this one, now it's s plus 5, so it's starting off looking like it's going to be one of these ones. So we need to complete the square first of all. Okay, so we're starting with this one for E. Okay, so we complete the square. S squared plus 4s plus 13. So it's going to be s plus 2 squared. This is exactly what we did on the previous bit. And then that's going to give us plus 4 when we multiply out. And because we want plus 13, we've got to add 9. Okay, so that's s plus 2 squared plus 3 squared, which is the start of these denominators here. So we've got a is 2 and omega is 3 to start off with. A is 2, omega is 3. Okay, but if you look in this numerator here, this here, it's s plus 2. Well, a is 2, and we've got s plus 5. So we need to do a bit of adjusting with this 5 next. Okay, and the way we do that, we say f of s is, we want it to be s plus 2 over s plus, oh, I keep doing that, s plus 2 squared plus 3 squared. But we also have another 3 because we actually want 5 on the top there, and we've only got a 2. So we separate that out, that extra 3 there. And that's going to be s plus 2 squared plus 3 squared. So what we've actually got now, we've got 2 added together. We've got this first one up here, row 8, s plus 2 squared plus 3 squared. And the answer to that, that's e to the minus at cos omega t. So this is going to be f of t is going to be e to the minus 2t cos, look, a is 2, 3t. Okay, so that's using this row here. And then this other one is what we had above. Look, it's exactly the same. It's that bit without the 9. So it's e to the minus 2t sine 3t. Or it's row 9 with k1, a2 and omega 3. Okay, so this one is going to be plus e to the minus 2t sine 3t. And you could always factorise this, cos 3t plus sine 3t. Okay, and that's your answer there. And again, I've checked that one, so that's right there. So E uses both of these rules, and D just uses the bottom one. So finally, we've got F now. And again, I've pulled out the rules that we are going to use because I've looked at the answer, worked out the answer before I've done this. So the rules we're going to use, row 4, this is going to come into it. Row 5, that one comes into it. But also the first shift theorem, which came up in question 1. And you need to, I think I mentioned it there, you need to learn this. And that's that the Laplace of e to the minus at ft is f of s plus a. So the a there goes there. We're going to use that for part of this. Okay, right, so to do this one, first of all, we've got to separate this out with partial fractions. So we say 1 over s plus 1, s plus 2 squared. It's a over s plus 1 plus b over s plus 2 plus c over s plus 2 squared. Then we multiply both sides by this denominator here, s plus 1, s plus 2 squared. We get 1 is a. Now the s plus 1 is going to cancel there and leave s plus 2 squared. Here, the s plus 2 is going to cancel, so it's s plus 1 times s plus 2. And this one here, it's going to be c times s plus 1. So we need to find the a, b and c. So we say, first of all, let s is minus 2. And then that gives us 1 is a times nothing plus b times nothing plus c times minus 2 plus 1. Okay, this is 0 because minus 2 plus 2 is 0. And here, minus 2 plus 2 is 0. So the B one becomes nothing there. So 1 is actually equals to minus C. So therefore, C is minus 1. The next one, let S is minus 1. I've picked that. The reason I'm picking these, I picked minus 2 to make this bracket 0. I picked minus 1 to make this bracket 0. So then we have 1 is A times minus 1 plus 2 squared plus B times nothing plus C times nothing. So therefore 1 is A times 1. So therefore A is 1. And the final one, let S is nothing. Okay, because I've exhausted the possibilities with minus 2 there and there and minus 1 there and there. So I've just got to pick a third value and I pick nothing. So we have 1 is A times 2 squared plus B times 2 plus C times 1. So 1 is 4A plus 2B plus C. So 1 is 4 because A is 1 and 4 times 1. Look, A is 1 from up there. So 4 times 1 is 4. B, we don't know what it is. C, there, but C is minus 1 in there. So it's plus 2B, and then plus C is minus 1. Come over here to save a bit of space. So on this right-hand side, I've got 3. 1, take away 3, minus 2 is 2B, so therefore B is minus 1. Okay, so now we've got f of s. We can write it as 1 over a over s plus 1, which is 1 over s plus 1. And then b, which is minus 1 over s plus 2. And then c, which is minus 1 over s plus 2 squared. So that's substituting the coefficients. Yeah. Substitute the coefficients sub a, b, c into star. And we get this. That's what's gone on there. Okay. So you can just see this here. Right, this one here, s plus 1, this is one of these on the right-hand side of the table. So we've got a is minus 1. And then the next one there, plus 2 there. So there's a 2 there, so we're going to put a 2 in there for this second one with that minus sign. Okay, and this is the one that we need the shift theorem for. So I'll just start writing some of these out now. You can say, breaking them down into bits. If we've got f of s is 1 over s plus 1, f of t is e to the minus t, and that's from row 4. Next one, f of s is 1 over s plus 2. F of t is e to the minus 2t. Again, that's an application from row 4. And then this last one, if we've got f of s is 1 over s plus 2 squared. Okay, so remember the first shift theorem, Laplace of e to the minus at f of t equals f of s plus a. Okay, so we've actually got, if we say Laplace of e to the, because we've got, we've got to do a bit of reverse engineering here. We've got a 2 there, so a is going to be 2, so we're going to put a 2 in there. Laplace of e to the minus 2t f of t equals f of s plus 2. Okay. So if we've got s plus 2 squared here, it's one of these with n is 1. So you see s plus 2 with n1, that's going to be s squared on the bottom, 1 factorial, which is 1 over the top, on the top. So this is t to the power 1. Okay, so if you think of that, so we're doing reverse here. Laplace of e to the minus 2t, t to the power 1, is 1 over s plus 2 squared. Okay, so we've actually got here f of t for this one, when it looks like this, is e to the minus 2t times t. Okay, so let's put all those together. So that's the thinking that I did there, but you can obviously take shortcuts when you've had a bit of practice of these. Okay, so putting it all together, we've got f of t is e to the minus t for that one. And then this one, we've got a minus there. So it's minus e to the minus 2t for that one. There, I've used that one and I've used that one. And then this last one is minus t e to the minus 2t. So basically that t I put in the front and the minus is up there. And that's our answer for that one. And I think that's question 3 completed.